All right, welcome back to the last two problems from your spring break packet. So here we have number 41. Take a read through and come back. Okay, so a couple of things that you should notice. It looks like we have a right triangle here in the center, like an upside down right triangle. So you're thinking about all of the things that have to do with right triangles. Pythagorean theorem, trig, special right triangles, all those things. All right, now what this question is saying is that this piece, A, is going up and down along this bar from C to D. It goes up and down, up and down. At this current position where it is right now, it's saying that the distance from A and B is 5.2 feet. The question is, find the value of theta, which means angle. Find the measure of the angle when it's in this position right now. Now, I'm going to go ahead and I'm going to highlight where that right triangle is so that you see it. Our right angle should be here. Okay, so we're going to be looking for theta. If I redraw this right triangle so we can label in some measurements and what we're looking for, I'm going to redraw. All right, here's my right triangle. I have my right angle here. I have this top distance being 3 feet. I have this hypotenuse being 5.2 feet. And my goal is to find the measure of this angle, theta. I'm going to be using trig. Trigonometry is the only thing that can help you find an angle measure when all you have is side lengths. So you have to use trig. Now we start off by labeling in our opposite, adjacent, and hypotenuse. Here's our opposite. Notice we don't have it. Our adjacent is the 3 feet, and then our hypotenuse is 5.2 because it's across from the right angle. So we're going to use a trig function that uses A and H because those are our only two side lengths, which means we're using cosine. So we're going to set up our trig function. We're going to write down cosine of theta equals our adjacent, which is 3, over our hypotenuse is 5.2. Now, how do we get the angle? We do inverse trig. So all of the stuff in the calculator that says sine to the -1, cosine to the -1, tan to the -1. So we're going to be typing into our calculator. To get the theta, we're going to do cosine to the -1 of this fraction, 3 over 5.2. And that is going to give you theta. All right, so in our calculator, we do 3 divided by 5.2. It's going to give us this decimal. I know you can't see, so let me get it in screen. Okay, so now our decimal is on screen. It's about 0.57 for that ratio of 3 to 5.2. Now we're going to hit the second cos button. In this case, the cosine to the -1 is already active, so I'm going to click cosine to the -1. And it's going to spit out the angle measure. It's saying that it's about 54.7 degrees. Looking at our choices, 54.7 is closest to 54.8. And it would be the 54.76 if I rounded to the nearest tenth of a degree, which is what it was asking me to do. So my answer is choice C. Let's take a look at the last problem. All right, our last problem here is number 44. Take a read through and come back. Okay, so Luke has this plot of land. Now, the plot of land is represented by the big trapezoid here that I'm highlighting in red. That is the plot of land, and on his land he's going to build a warehouse and the parking area. All of these coordinates are supposed to represent feet. So part A says, what's the perimeter of the plot of land rounded to the nearest tenth of a foot? So for finding perimeter, we need to add up all of the sides. Now, I'm going to start with the bottom length. If we're going from 0, 0 to 50, 0, that means we've gone to the right 50 units. In other words, 50 feet. So the bottom length here, I'm going to label in, is going to be 50 or 50 feet. Now this vertical length from 0, 0 up to 0, 60. We're going from 0 up to 60. So that means we went up 60 boxes or 60 feet. From the top left corner, 0, 60, to 70, 60. Notice the y value didn't change. It was 60 and 60. So all we're doing is we're moving to the right. From 0 to 70, we've moved to the right 70 boxes. So it's 70 feet. And now the last length that we need to find is this diagonal one, which means we're going to have to do some trig. This is like having points on a grid, and that's when we, not trig, I'm sorry, Pythagorean theorem. This is like having a right triangle or line segment drawn on a coordinate plane, where we always use Pythagorean theorem instead of the distance formula because it's quicker to find a missing length. So what I'm going to do is I'm going to draw in a little right triangle here so that I can see where my hypotenuse is and what measurements I need to use for Pythagorean theorem. So I'm going to draw a box that goes down, a line that goes down and over. Okay, so if I'm going up, down from 70 down to 0, this is 70 boxes. And then I went down from a x value of 60. So down here, this would be 60, 0. So between this point, 60 and 50, we have 10 boxes. So it's 10 for that bottom length. So if I need to find that diagonal, I'm going to do 10 squared plus 70 squared equals my hypotenuse here, c squared. In my calculator, I can do 10 squared, which would be 100. 70 squared, I don't know what that is, so I'm going to put that in. 70 squared, 4,900 equals c squared. Add them together. Now I have 5,000, which is c squared. And to get c, I'm going to square root. Square root button, here it is. So it's 70.71, so it's set to the nearest tenth, so I'm going to call this 70.7, because that's the only one I'm going to be rounding, equals c. All right, now to get my perimeter, I'm going to have to add them all together. So I have 70.7 plus the bottom of 50 plus the height of 60 plus, what was that? Base up top was 70 again. Okay. So now I'm going to write down 70. I'm going to add all these together. I kept that 70.7 in my calculator. I'm not even rounding into the very last step. I just rounded in between when I wrote the number down. Now I'm going to add 50 to that. Add 60. Add 70 again. And it's 250.71, yada, yada. But if I'm rounding to the nearest tenth, my answer here is 250.7 feet. Next, what is the area of the plot of land? That does not include the warehouse and the parking area. So that means I'm going to be subtracting the area of the warehouse and the area of the parking area because I don't want to include them. All right, now this is going to require a little bit of work. If I want to find the area of the whole plot of land, I'm looking at a trapezoid. So I'm going to find the area of the trapezoid. Area formula for a trapezoid. Area equals 1/2 times height times base 1 plus base 2. Now my height in this problem is my 60. That's my height. Okay, so I'm going to put in 60. Base 1 and base 2, that's the top and bottom of the plot of land, so 70 plus 50. All right, so I'm going to do 1/2 times 60. 70 plus 50 is 120. I'm going to multiply all that together. So 120 times 60 divided by 2. 3,600 is the area of the whole plot of land, but that's not my answer because I need to subtract the area of the warehouse and subtract the area of the parking area. Now, this is going to require a little bit of work. Now, to find the area of the warehouse, we're going to have to figure out the measurements, the base and the height of what looks like a rectangle for your warehouse. So I'm going to start at the top. So to get from 450 to 3950, I had to go to the right from 4 to 39. That would be 35 boxes to the right. So my base here is 35. Now my height, I went from 3920 up to 3950. So the only thing that changed was my Y value. To get from 20 to 50, that means I went up 30 boxes. So the area of this warehouse, this would be 30 times 35. So it would be 1,050 for the area of the warehouse. Now the parking area is a trapezoid. So I'm going to have to know the base 1, the base 2, and the height. So my height, to get from 40 up to 420, my height is 20. To get from 40 to 50, which is this bottom base, I had to go to the right 46 boxes. And then for my top base, to go from 4 to 39, I had to go 35 boxes. So those are my 3 measurements that I need for area formula. Now let me work out the area of the parking area. So I'm going to have area equals 1/2 times the height times base 1 plus base 2. 1/2 the height of 20 times base 1, let's say that's the top, plus base 2, which is 46. Let's work this out in the calculator. 35 plus 46 equals 81. Times that by the 20, your height, then divide it by 2. So 810 is the area of the parking area. Now, to get just the area of the land, not including the warehouse and the parking area, we have to subtract the 2 areas we just found. So our goal is to take the 3,600, the whole area of the land, subtract the parking area, which we just found to be 810, subtract the area of the warehouse, which we said is 1,050, and now we do that in our calculator. So 3,600 minus 810 minus 1,050. So our area of just the land is going to be 1,740 feet squared. All right, last question, part C, is asking you to fence in the parking area, but just the legs. So they're just looking to fence in the 2 legs of the trapezoid. So I'm going to zoom in. Let's see what the 2 legs are. All right, so I know one leg. One leg is the 20. I need to find this other leg, which means I'm going to have to do Pythagorean theorem again. So I'm going to draw in a right triangle. So I'm going to draw a line down here. I'm going from 20 down to 0. So that's going to be a height of 20. And then I want to go across. So I'm at 39. I want to get to 50. So I'm going to the right 11 boxes. So 20 and 11 are my 2 sides, the 2 legs of the right triangle that I'm going to have to use for Pythagorean theorem. Let me go ahead and give myself some room. All right, so 20 squared plus 11 squared equals c squared. So it's 400 plus 121 equals c squared. Add those together. 400 plus 121 equals 521. 521 is c squared. I'm going to just get c by taking the square root. So now I have 22.8254 as the length of one leg. And then the other leg we saw was really simple. It was just 20. So now we're going to add the 2 together. So our entire perimeter for the 2 fences needs to be 20 plus your 22.8. So in my calculator, I'm just going to add 20. So I have 42.825 as the amount of fencing that I need. So to the nearest 1/10 of a foot, like the question asked me, I'm going to write down that my answer is 42.8 feet. And now we're done with that question. And it was a long question and required you to understand how to find the distances using the coordinates. If it's a horizontal distance, the only thing that's changing is the x value. So that's what you pay attention to. Vertical distance, the only thing that's changing is your y value. So that's what you pay attention to. Okay, and that finishes out your spring break packet.